Alrighty, 8th graders, welcome back to part 2 of lesson 10.5. We are going to continue on here with the next few examples, and then we will talk through what is expected of you from your homework and what you need to make sure you're getting done, okay? So example 3 then here says an object with a lesser density than water will float. Okay, so things like feathers usually float. What else are good things? Boats. So like boats are kind of tricky because there's a way you can make them less denser in a way than water. But some other kind of things that'll float in water, like certain paper, if it doesn't get too wet, or like um, sometimes like balls, like balloons, things like that. So an object with lesser density than water will float. An object with a greater density then will sink. So things like rocks, or like if anyone's done the egg test before, so I do this all the time to check if my eggs are actually good. You can put in a glass of water, you can drop in an egg. If your egg sinks, it is perfect. You can eat it. If your egg floats though, that means that it has gone bad and you need to throw it away. Anyways, use each given density in kilograms per cubic meter to explain what happens when you place a brick and an apple in water. All right. So obviously you can already kind of assume that you would think that a brick would float, but let's double check because maybe it's made out of some other material. Maybe it's not going to float or sink. Maybe it's going to float. But I'm not sure about the apple. To be honest, the apple could float. The apple could sink. So we need to know how much of a density water is. So right now, all these things are written in scientific notation. And what I would do is that I would change these all to standard form. That way it's a lot easier to read because at this point, I can't just like look at the factor and decide that one is bigger than the other. So we're going to go ahead and change these all to standard form. So I'm going to start with my first one, my water. It has a power to a +3, so I'm going to move it 3 to the right. So 1, 2, 3. So if I add in my extra zeros, it looks like I'm getting a density of 1,000. Okay, 1,000 kilograms per cubic meter. All right, my brick looks to be the same thing. It's multiplied by a power of 10 to the third, but my factor is different. So I'm going to rewrite this out. We are going to move my decimal place 3 to the right. 1, 2, 3. So I only have to add in one extra zero, so it looks like I got in 1,840. So the directions say that an object with a greater density then will sink. So right now I can already tell, basically given my already predicament, that the brick is going to sink because its density, this number, is greater than this number. So I can write that this is going to sink. Boom, sink. All right, let's see about our apple though. I'm not sure. So what we're going to do is we're going to take this number, 6.41, and we are going to move the decimal place 2 to the right. So 1, 2. So it looks to be that I get an answer. So my decimal place would be right at the end. I know this was a little, little misconstruing here. So it's going to be 641. Again, bear with me on my writing here, not pretty. I'm working on getting a little writing pad here for my computer. Hopefully it'll come any day now, so the next videos will look a little cleaner. So this is 641. If we compare it with water, then 641 is smaller, so that means that if it has a lesser density, my apple will then float. So this is a way where scientists will sometimes use these scientific notations if they don't want to write everything out, especially when they're again looking at even bigger numbers than this or even smaller numbers than this. All right, let's go on to example 4. So I don't really like the premise of example 4, but we will continue on just because it looks so gross. But example 4 is talking about a dog, okay? And dogs tend to get fleas sometimes. So what happens is dog has 100 female fleas. So there's 100 female fleas on this dog. How much blood do the fleas consume per day? So I want to know how much blood out of this dog are the fleas consuming, okay? Because I want to know maybe how sick this dog's going to get. This might be something that a veterinarian or a vet tech might need to take in consideration on, how long did this dog have the fleas? Okay, well, if he had 100 fleas for this many days, how much blood is he losing every single day, and how are we going to treat him? Or her, whatever the dog is. So what it also says that a female flea consumes about 1.4 times 10 to the negative fifth liters of blood per day. So this is going to be important to tell me how much each flea consumes each day. There is 100 female fleas though. So what we're actually going to do is I want to convert this into a power, okay? So with a base of 10. So 10 to the power of what would give me 100? Well, 10 times 10, so to a power of 2 is 100. So I'm going to have 10 to the second, okay? So we are going to take this number, and one way we can do this, I'm going to kind of show you two ways we can do this. One way we can do this is first find this in standard form. So I'm going to put my 1.4, and it is to a power of -5. So that means I'm going to move my decimal 5 places to the left. Should have left a little more room, but let's do this. 1, 2, 3, 4, 5. All right, so then I'm going to add in my zeros. Again, it's not going to be pretty. So this is how much blood one flea will consume in a day. So I've done it this way where I first figured out what this is in standard form, okay? I need to figure out, though, 100 female fleas. So basically, what's going to happen is I'm going to take this number and now I'm going to multiply it by 10 to the second. Now, typically this is not written in specific standard form, but the rules still apply. Because now I have a positive power, I am going to move my decimal place back to the right 2 times. Sorry, my nose is really itchy. Sorry if I sneeze, guys. All right, so moving my decimal back over to 2 places, okay? So then my official answer would be 0.0014 liters of blood. So that's one way. You can first take this number, write it in standard form, and then go back and multiply it by 10 to the second. Or another way is I can take this whole thing, rewrite it out. Ooh, takes a little minute. And then I'm going to also multiply it by 10 to the second, okay, because there's 100 of them. Using my exponent rules, I can make this simplified. Go ahead, and then since this is being multiplied here, you just add your exponents together. Well, a -5 plus a +2 then is going to be a -3. And then I only have one step where I have to move my decimal. So I'm only going to move my decimal here then 3 to the left. 1, 2, 3. So then I also notice I get the exact same answer. Okay, so 2 different ways you could do it. Pick whatever way is a little easier for you when you are solving out a problem like this and you have to kind of reconvert it depending on how many of that thing there is. All right. We're going to skip the on your own part, so don't worry about it. Cross it off on your sheet. Just don't want to really get through it. If you want to challenge yourself to do it, you can as well if you want, but I'm not going to go through the answers. Alrighty, so again, workbook is yours to use as your discretion right now. So if you want to work on some of those problems, you can for extra practice or to help you review. But I'm not going to be grading it. So then your homework is going to be up online here on the 27th is when it will be uploaded. So make sure you're looking out for that. Let me know if there's issues looking for it. It will be due then on that next Sunday, which I believe is the 3rd of May. We're already getting into May, guys. Whew. All right, so this is due then, due 5/3. So make sure you're getting those homework done the week they're assigned. So it's going to be due here on Sunday. Okay. If you didn't catch the code word, make sure you go back and find your code word where it is in case you have any problems or needing help with that. A few people I've already had to kind of ask them for the code word because they're not doing so well on the big ideas math. So make sure you're taking your time. Okay. Otherwise, I hope you have a wonderful day. I will catch you later. Talk to you then. Bye, guys.